You often heard weightlifters called power lifters, right? Or industrial facilities that generate electricity are also called power plants. If you are into car racing, you would of course go after one that accelerates rapidly, right? Knowing the science of your car engines means that you should understand how much work is generated in an engine for us to declare it powerful. For this lesson, you will be learning about how one can predict the rate of energy usage, not just in cars, but also in physics. What is the first word you think of when you hear the word power? If you said electricity, then we are the same. Confusing as it may seem, power can be clearly produced in different means. Let us say you climb up the stairs at your usual pace. Say you did a displacement of 2 meters in 5 seconds. Then, your friend climbs the same stair, hurriedly doubling your pace. Although the work you both done is completely the same, the time it took your friend to climb up the stair is different, thus giving the two of you two different power outputs. In easy comprehension, power can be described as the rate at which the work is done. Going back to our previous example of climbing up the stairs, computing for the power output involves work as a combination of the potential and kinetic energy of the individual. At this point in time, one can also describe the rate of energy usage. Thus, when we add the potential energy and the kinetic energy gained and dividing it by the time elapsed, this will result in power output of a person. The SI unit of power is watt and symbol big letter W, named after English inventor James Watt. Here are some equations we need to remember when dealing with power. P is equal to W over T, where P is power, W is work, and T is time. Can you still remember how we defined work in the previous lectures? Correct. Work is defined as the product of force and displacement, whereas power can be well associated with force and velocity. Mathematically, we can compute power as P is equal to Fv. Lastly, since energy is related to work, we can also express the equation as the rate in which energy has been used. Power has the units of energy in joules per unit time. In other words, J over S is equal to 1 watt. Thus, this yield to the equation P is equal to E over T. In the next video, we will have some mathematical examples of power and its application in our daily lives to have a complete grasp of what we are talking about. That is all for this lecture, and see you in the next video.